Welcome to my class of operating system. Today we will learn protection and security design principles. First of all, let me learn what is security. Let me recapitulate. We have already covered security and protection, the definition and its different features in last class. The security system covers the safety of their system resources. System resources is saved data, memory disk, etc. across malignant alteration, illegal access, and disparity or consistency. The security gives a mechanism to analyze the user to permit for using the system. Protection deals with the access to system resources. It determines that what files can be accessed or permitted by a special user. The protection of the system should confirm the approval of the process and the user. Due to this, these licensed user and process will care for central processing unit, memory, and alternative sources. Hardware is mainly vulnerable to interruption, either by theft or by vandalism. Physical security measures are used to prevent these attacks. Software is also vulnerable to interruption as it is very easy to delete. Backups are used to limit the damage caused by deletion, modification, or fabrication through alteration. Example by viruses is a major problem as it can be hard to spot quickly. Software is also vulnerable to interception through unauthorized copying. The problem is still largely unsolved. Data is vulnerable in many ways. Interruption can occur through the simple destruction of data file. Interception can occur through unauthorized reading of data file, or more perniciously through unauthorized analysis and aggregation of data. Modification and fabrication are also obvious reasons with potentially huge consequences. Data is vulnerable in many ways. Interruption can occur through the simple destruction of data files. Interception can occur through unauthorized reading of data files, or more perniciously through unauthorized analysis and aggregation of data. Modification and fabrication are also obvious problem with potentially huge consequences. Communications are vulnerable to all type of threats. Passive attack take the form of eavesdropping and fall into two categories: reading the contents of a message, or more subtly analyzing pattern of traffic to infer the nature of even secure message. Passive attacks are hard to detect, so the emphasis is usually on prevention. Active attacks involve modification of a data system or creation of a false data stream. One entity may masquerade as another, presumably one with more or different privileges, may be capturing and replaying an authentication sequence. Replay is a similar attack, usually on data. Message contents may also be modified, often to induce incorrect behavior in other users. Denial of service attack aim to inhibit the normal use of communication facilities. Active attacks are hard to prevent, so the emphasis is usually on detection and damage control. Protection. Multi-programming involves the sharing of many resources, including processor memory, I/O device program, and data. Protection of such resource run along the following spectrum. No protection may be adequate. Example, if sensitive procedures are run at separate line. Isolation implies that entities operate separately from each other in physical sense. Share all or nothing implies that an object is either totally private or totally public. Share via access limitation implies that different entities enjoy different level of access to an object at the gift of the owner. The operating system acts as a guard between entities and object to enforce correct access. Share via dynamic capabilities extend the former to allow rights to be varied dynamically. Limit use of an object implies that no one is access to the object control. The use to which it may be put also varies across entities. The above spectrum is listed roughly in order of increasing fitness of control for owner and also increasing difficulty of implementation. Actually, protection deals with the access to the system resources. It determines that what file can be accessed or permitted by a special user. The protection of system should confirm the approval of the process and users. Due to this, these licensed users and processes will care for the CPU, memory, and alternative sources. The protection mechanism ought to provide a path for specifying the control to be obligatory besides how to implement them. Example of protection can be given from the security. Any organization will have many departments that staffs operate. The assorted department will share frequent info with one another, however not sensitive information is shared. So completely different employees have different access right the info into the step with that they will access the defined data. Computer protection and security mechanism provided by an operating system must address the following requirement: confidentiality or privacy. The requirement that information maintained by a computer system be accessible only by authorized party, users, and the processes that run represent those users. Interception occurs when an unauthorized party gains access to a resource. Example include illicit file copying and the invocation of programs. Integrity, the requirement that a computer system's resource can be modified only by authorized party. Modification occur when an unauthorized party not attending gain access to but changes a resource such as data or execution of running process. Availability. The requirement that a computer system be accessible at required times by authorized party. Interruption occurs when an unauthorized party reduces the ability to a resource. Authenticity. The requirement that a computer system can verify the identity of a user. Fabrication occurs when an unauthorized party insert counterfeit data amongst valid data. Protection and security design principle. Least privilege. Every object means user and their processes, should work within a minimal set of privilege. Access right should be obtained by a explicit request, and the default level of access should be none. Economy of mechanism. Security mechanism should be as small and simple as possible, aiding in their verification. This implies that they should be integral to an operating system's design and not an afterthought. Acceptability. Security mechanism must at the same time be robust yet not so intrusive. An intrusive mechanism is likely to be counterproductive and avoided by users if possible. Complete mechanism must be pervasive and across control, checked during all operation, including the task of backup and maintenance. Open design. An operating system's security should not remain secret, not be provided by stealth. Open mechanisms are subject to security review and continued refinement. Now, security and protection, policies and mechanism. Security policy specifies whether a person can become a user of the system. This function is performed by the system administrator. Mechanism: add or delete users, verify whether a person is an authorized user. Protection policy specify whether a user can access a specific file. The owner of a file performs this function while creating it. Mechanism: set or changes protection of information for a file check whether a file can be accessed by user. Security models. Security model can be discretionary or mandatory. Discretionary: holders of right can be allowed to transfer them at their discretion. Mandatory: only designated roles are allowed to grant right and user control transfer them. Security models, as we have already discussed, it is discretionary or mandatory. Role-based access control. Enforce access control depending upon a user's role. Role represent specific organization duties and are commonly mapped to job title, for example, administrator or developer, etc. Take grant model. This model use graph to model access control. The graph structure can be represented as an adjacency matrix, and levels on the arcs can be coded as different values in the matrix. Nodes in the graph are of two types, one corresponding to subject and other to object. The possible access rights are read, write, take, and grant. These are the possible access rights. Security policy versus security model. Security policy outlines several high level points: how the data is accessed, the amount of security required, and what are the steps when these requirements are not met. Security model, the mechanism to support the security policy. These involves in the design of security system. Protection versus security. This is a comparison. By definition, main focus, by functionality, and by mechanism. First of all, let me keep this in mind that security grants the system access to the appropriate users only, while protection deals with the access to the system resources. By definition, protection is a method used in operating system that manages threats with system to maintain the proper functioning of system. Security is a method used in operating system that handles the threat from outside the system. Main focus on protection is focus on internal threats of system. Security focus on external threats to the system. By functionality, protection provide a mechanism for controlling the access to program, process and user resources. Functionality provides a mechanism to safeguard the system resource and user resource from external users. In security, external threats are involved, while in protection, internal threats are involved. By functionality, it provides a mechanism for controlling the access to program, process and user resources, whereas security provides a mechanism to safeguard the system resources and use resource from external users. By mechanism, protection involves mechanisms such as setting or changing protection information of a resource and checking whether the resource is accessible by a user. Security involves mechanisms such as adding or deleting users, verifying whether a specific user is authorized, using anti-malware softwares, etc. In security, more convoluted queries are handled, whereas in protection, simple queries are handled. Security illustrates that which person is granted for using the system, whereas protection determines that what file can be accessed by permitted by a special user. Thank you for watching.